And so here is the outline for today. At the very beginning, I'm not going to talk. We'll have your progress report. And then afterward, we will go for the Q&A. And then after that, I probably will have a small break. So you will find out our today's break is a lot earlier than before. It's because I don't want to having something in the middle when I talk. And then I will finish the concept of language and the basic understanding about the NLP. And then we're moving on to two very important ways to represent things. They are totally two different concepts. And this semester, I try to use different example. I hope that is easier for you to understand. And then no matter what is the time, so which means no matter it's already 11:40 or 11:50 or 12 o'clock, I don't care. I just need to finish the word today. Okay. And then why? Because next week, we are not going to meet here. Ha ha. Okay. I'm still wrong, but the thing is like we're going to have a lab 2. If you feel like, oh, I have finished my lab 1, or I'm still in my late submission for lab 1, and then you're going to have lab 2? Yes, we are going to have the lab 2. And the TA are very proud to tell me that, Professor, I did a lot more requests than last year. Then by actually last year we only do the text. But this year, and TA are just so happy for you to know how to utilize some mechanism then for the image data as well, because people asking about image. And then they're do having one thing for you to know. I hope you guys received the late submission penalty announcement. Okay, and there's one policy for you to know. I don't like to fail students. I hate failing students. If you work very hard enough, then we think you deserve a chance. So if you actually are struggle enough for having a lab 1, remember you still having the chance to submit it late. And then I think the TA already tell you how we calculate in that email. I remember we write that. I would like to say that again right here. Saying that, so for example, we still suggest you to submit whatever you have to get some score first. So assuming, and because you don't have the time, you don't know what's going on, by the way, people usually accumulate what they know, and in the end, that in the very beginnings, in the semester, very beginning, when you try to work in with the lab 1, you feel that is so difficult. Maybe in the end of the semester, you will feel it's a lot easier than you thought. Okay, we usually see that problem. Okay, so then I think that is nice. And then let me try to finish the QA, then we can have it. So, some people are actually asking about how can I handle the big set, or for example, KN try to do that efficiently. Okay, because if you actually know the KN we mentioned in the class, the complexity is quite high, and then we usually can combine with some of the dimension reduction or deduction technique, such as SVD, SVN, or costing mechanism. Of course, some of them, for example, costing, we did not talking about that. You actually will find out in today's progress report. A lot of people already talking about RNN, transformer, and that. We don't actually have to talk about that yet. But then, if you actually try the final project, you will understand that even though you don't know how they really work on, but then you know how to input them, how to get the output, the rest of them rely on the package. How to use like KNN as its application. Can usually be mentioned in the recommendation system. If you want to recommend is anyone similar to that, so for example, in Yushan competition, you can utilize KNN too. By doing what? You see some fraud. You're so certain about the fraud. Then you can actually find out is any nearest neighbor more likely to be fraud. Okay, so in that case, KNN can be tried. You don't really need to thinking about it should be considered as a classifier. No, the K1, why we actually list them in the classifier, because that's a class similar to you. So the class is not defined as the traditional class. The class is defined as that is the object that we're talking about. So in Yushan, you can actually find out what is the nearest neighbor about the fraud. Or actually, you can say if what is the nearest neighbor that about this account. Okay, who usually associate with that account? Okay, and then if there's any account that are likely to be fraud, the nearest neighbor probably could be fraud too, even though that in your timestamp or time series sync, they're not thinking about that. So that is how the KN can be used. Okay, and so then why we're actually thinking about that? Because we're just thinking about if they share the same interest, they are likely to enjoy the same thing. Okay, just like a fraud, if that is to be identified as fraud, and the people actually have the similar pattern to it, you would like to do with fraud. And I frequently actually receive from 1 minute reflection, Professor, can you talk this? Can you talk that? Can you talk this? I would like to know more, and something like that. And then first, our time is very limited. And then we can only prioritize few things in our course. I would like to utilize some illustration right here. Okay, this is the time we're going to have. For every class, they were having some goal. So for example, if you took machine learning course and their objective will be different from data mining. Objective of machine learning is they're having some classic different way of the machine learning approach. And then it will select different, because they are classic, there are different type of them. But they probably will say, this is one type, tree-like. This is a metric-like. And this is something. So they are select certain part. That is the part they try to select. In our data mining courses, there are big concepts I want to deal with. And one thing is I want students to know how to deal with the data. So that is why we spend so much time on actually on the processing, tell you, okay, you see that data, and maybe we can utilize this way to treat with this one, how people try to deal with the data. Then, can you actually understand something that we did not officially being indicated that in any textbook? Usually we're thinking about there are just experience. Can we share that experience right here? Okay. If that's the case, then you will find out there have a lot of time that's been go through share those experience. Then afterward, I also want to know, I want to let the student to know how I can evaluate them, how I actually can observe things. When I get this result like this one, does that really reflect what it means? It might reflect to something else. So can I utilize different angle to working with that? So in that case, you will find out my big stone in my can right here actually already occupied quite many times. Yes, it's different from machine learning. So then afterward, I also need to talking about certain technique. The way I'm talking about technique is I want you to know how it will be related to the data you would like to process. So you will find out my angle to talking about those techniques very different from the courses you take. Okay, some people might feel like professor, but then I don't know the depth. If you want to go to the depth, you're working on that on your own. Okay, so you are having some smaller stone right here. Sometimes I probably will give you the smaller stone. It's like here. Okay, so I give you some turn and thing for you to do. And then every other thing is some like water can be filled in is based on your interest. And then you need to working on that. Okay, we cannot provide everything to you. But then we would like to, every time in our classes, we give you a roadmap for you to know how to learn. So then that roadmap probably is just a terminology. You might say, Professor, can you talk more? No, we cannot because our time is really limited. So you can find and explore the concept, utilize that as a keyword, go to Google Scholar, and or actually go to YouTube to find out like 1 minute session about something or 5 minute session about that. You actually can find 1 hour, 2 hour, depends on what kind of depth you want to go through that. Okay, so that is the part we want to talking about then. Yes, something are so important. Why we not talking about that right here? Because we don't have time. And also, if I talk everything in this class, what else you need to learn in other course, right? So then you need to take so many courses. In other words, every professor actually was choosing the concept they think that matter a lot in this section. If you take the courses, different courses, they're almost talking about the same thing, then I think you probably waste your time too. How can we know when the time stop improving? I mean, they're talking about learning model. Is there any technique or way? And then I go back to thinking about my slide, and I realized I forgot to mention some keyword called loss. Okay, in a lot of machine learning courses, they were talking about the term called loss function. And loss function is like, what is loss? The difference between model predict output and your true label. What is the class? And then we will indicate how good your model is trying to performing. So the smaller the loss, which means the better prediction. So you can actually see with the different generation or different epoch, and then what is the loss? Did they actually still dropping or actually they saturate? If they saturate, which means they stop improving. And if the loss is not available, so for example, you try different kind of package, and then certain package they don't have the loss, then you can directly test precision or you test recall, depends on what you actually think is more important. And the most important part is you need to see how the quality of your prediction classification result being indicated. Okay, so then I think that is more about our QA, and that indicate in your last 1 minute reflection. And how about we take 7 minutes break? And then we come back at 10:30. Okay, come back at 10:30. Thank you. Okay, so while you come back, let me talk about something I forgot to mention. In this week's progress report, then we got a team, like Team 40 from NTHU, Team 46 come from NTU, Team 13 come from Taiwan University of Science and Technology, and 28 come from NTHU, and 25 come from NTHU. And in the Keiko's team, 29 come from NTHU, 61 come from National Taiwan University of Science and Technology, 24 come from NTHU, no, 29 come from NTUHU and NCKU, and then 68 come from Danjiang University, and then 47 come from Zhengzhi University, and 9 come from NTHU. So I think congratulations for those groups. And then we actually will give you the CPU resources to reward you for your group work. Okay, so then I have time. Okay, so then we want to talking about the text mining concept. But before I jump in, I would like you guys to know what is language. Okay, why I still need to spend the time on the concept that are not technical related. You will find out I usually would like to bring the concept to our domain. Then you will know that from that domain to the technology is any gap between them. Okay, why? Because you are the person who bridge them. Okay? You need to know the gap. By understand what's the domain and understand is this technology. You are the person to become the bridge. So in your final project, you do the same thing. Okay? If you do not understand what is the project and then you directly try to apply for many things right here, then you will know that you're just circling around without any clue. But doing the final project, for example, for the team we try to select, you will find out they do the exploration, they come back to say, I probably need to segment them into this one. It might mean this one is related to that. So you come back to somehow digest about the information you go through and then propose the next one. So as another bridge. So every attempt that you try to do is try to bridge the gap between this reality to your future. So then natural language, first, you need to understand where the language comes from. And then based on the Oxford Dictionary, they say language are either spoken or written. So right now when we try to talk, we are doing the spoken. And then it will consist of a lot of words. And then we understand it. So that is why we say it's conventional way. You can understand me because it's convention. And also the way I talk has some kind of hidden structure behind them. So then we need to understand what's the hidden structure. And it's a very interesting hypothesis from Sapir-Whorf hypothesis. It says the language structure influences how speakers perceive and experience the word. And let me try to give you one example. But before I give you one example, I need to turn out the vote. Okay, why? So here are the photos of me. I'm very young, like last year. Okay. And then, so if you saw those photos, how are you going to order them? Go to the slide view, and then you're telling me that you want to order like this way, order like this way, or order like this way. Okay, so which one you prefer? Go to slide view, and then try to tell me how you try to order them. From top to down, from the left to right, or from the right to left. Okay, so let me see. We have 30 people vote. So 32, 35. Only 37 with us now. Go to the slide view. The best way is I know how many students are with me right now. In the September 29, around noon, I was in front of my computer to check how many students really finish about the recording. At the time, we're supposed to have the class. And then when 12, I come, and then there's only one. It's like, okay, one. And then wait for like that night, and then I got two, I think, 2 or 3. Okay, fine. Then let me try to upload my 1 minute reflection for you to understand how many people are with us. And then, okay, so then currently we have 65 students with us. Okay, so you will find out around like 80% of people actually do the left to right. Why you do the left to right? And then probably only 4% of them do the right to left. And then top down percent of people do around 18%. Why? Left to right, left to right, or right to left, or up to down. Why? Because we're influenced by the language we're using. Most of the time, particularly like in this class, like we mostly do left to right. Our language doing something like that. So then if you understand about that, you will find out the language are constantly influence us. The reason I say that is I would like you guys to know If you keep on saying a lot of stupid bullshit, then you are knowing that how it influences your mind. Everything you see are bullshit. That is terrible, right? And so then, if you, I don't know if the hypothesis is correct or not, because they do having some scientists try to prove it, and then not prove it, utilize some example to show how people being influenced by the language they use. And so please be aware of them. Okay, so then if the language actually is a communication, because we try to communicate between human beings, what are the fundamental problems for the communication? This guy, we saw him last time. Do we show his photo? Yes, right? Do you remember who he is? He proposed something, and then in the end, a lot of people keep asking, what is entropy? Okay, it's Claude Shannon, and Claude Shannon in his information theory, an interesting part is entropy is try to measure how good we communicate. How could we? Is any possibility the information we get lost? How random it is? Can we get confused? And they say the fundamental the problem in the communication is try to reproducing. I say something. How do I know you understand? You need to come up some other statement in your brain feel like you understand. Even for that one, probably it's not understanding because you actually will find out many students actually will write in the 1-minute reflection. Should be, I think I understand. But then, I think I probably also don't understand. Not clear. Many students in their 1-minute reflection will always write not clear. Probably it's because when you hear, just yeah. Is that true? You don't know. That is something that you need to reproduce. So then, go to the NTU pool, and then try to see what is the problem. Why reproducing them is so difficult. I think this exercise is good for the people who select the project on Kaggle. You have some brainwave, and you want to produce the language, how difficult it is. Okay, so what is the problem of the communication? And that example comes from one encounter with a student.
What's the name of the quiz?
It's called problem of the communication. You go to the tab, text mining, first one. It's the one you want. By the way, if your answer is different from me, don't worry about that. It's fine. Okay, so because of time limits, so you can actually see here's the statement. I think this example comes from some conversation between me and in the class. I asked the student, what is the limitation can CNN address? When I actually go through then, I was thinking about, last week I just talking about the CNN, and then we're also talking about some limitation. I think the students supposed it should be easier to catch up. However, quite many students tell me that is not clear. It's different from my expectation. By the way, it's very frequently happen. I say something, and then, for example, last night, I typed some keyword, type some statement on the worker conversation between me to our TA, okay? And then I saw several TA do that correctly, but one of the TA did not do that correctly, okay? So then, and after that, the TA questioned me, so the professor does that what it meant, and and in the end, he said, oh, sorry, professor, I misunderstood it. So even for me, with my TA, they're working with me for a long time. It's still having a possibility that we don't understand each other. It's very, 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 very common. Okay, and so then if you actually do not understand, so that's a good way for we to having that 1 minute reflection. Because if I do something not clear, you directly ask me next time. Have no problem. But then why the same statement can be interpreted in a different way? Okay, because first, one word that might having a different meaning. Okay, you know that in Mandarin, you know that in English, there's some English say the buffalo, 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 buffalo. Have you heard about that statement? You will know later on. We will try to give you buffalo, 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 buffalo. I think it's just like that. Many, many buffalo. And then they're just, you know, buffalo is the very big bull. So how you try to say it's buffalo? It's a very big one. And the buffalo can also mean location. Buffalo can also mean bully. Okay, so then in the end, the statement is a buffalo, a cow, in some way, in Buffalo, that city, and then bully another buffalo. That is the meaning about that. So you actually see buffalo, buffalo, buffalo. And it's legal statement. Okay, and in Mandarin, we're also having a lot of statement like that. And so then you can actually see that one single word can have different meaning. So you don't actually know which word, this word is supposed to mean what. How you know it? You need to base on the information surrounding by it. So right here, I will want to talking about the thing, context. Okay, context. Because the information surrounding by you is context. Remember in the beginning of this class, we draw you, and we draw the yellow shadow surrounding you. Okay, and we take out person, the red one. You still understand that. How can that be understand? Because the context can define the middle too. Okay, but sometimes during the communication, we don't know the context. Why? Because my context is different from your context. In that cases, then we might having the misunderstanding to each other. Because when I mention that, it doesn't mean that. But then our context different. So it comes to totally different meaning. And the context come from the different background, come from different experience to understand them. But you need to really respect that variety. When you do the final project, also remember that you have a lot of accounts. Different accounts have their own context. Can you differentiate the different type of the context? Okay. And the structure of the statement can also be interpreted different way. In Mandarin, we having a statement, an example, say 下雨天留客天留我不留. Right? If you know that, it's like it can be translated. Sorry for our international students. It can be translated as like it's a raining day, and will you treat me to stay in your home? Okay, then the answer is yes. And then you can also say that it's a raining day. Can I stay in your home? No. So the same statement it can be translated in different way. And because why is like that? Because we structure them. So how can we interpret what's the limitation of CNN can be addressed? What kind of context we can bring right here? If you ask a question, thinking about context of today is about data mining. And today, actually, we're talking about a model, a neural network model called convolutional neural network model. Then in that case, you will eliminate the cooperation, broadcasting cooperation here. Okay, because it's not in our context. So that is the way how we try to understand each other by filtering out the impossible context out of it, and then we were having the illegal one in the middle. Okay, so then right here, please understand, I think they're still having 5 people. They are good. There's no way they were misunderstanding any statement given in the class. Good. Then I hope you won't have any problem during the final exam too. Okay, so you can see how the communication looks like. Someone says certain thing, like CN can address which limitation we're talking about. And what we need to do, so first, you need to somehow decode that statement. How we decode? You know what is the key word, key concept right here. So for example, we will actually pick 2 key concepts. That is CNN, that is limitation. Do you see some common between them? They're all none, right? That is why you will find out when we try to working on the natural language processing, a lot of people would like to talking about what is the verb, what is noun, what is something else. Because different role of your word serve the different action. Okay, for example, like right here, we actually would say, if you want to know what is the most important action right here, you need to pay attention to the verb. Okay, like right here, we want to talking about can address as a verb. Can is a verb, address is a verb. Can address is a verb. Then we actually saying, okay, CNN can do certain action by that limitation. So you try to decode them. After you decode them, then we need to bring all the context right here. The context right here is like our last session, we're talking about the convolutional neural network. And then, so then you probably will say, oh, convolutional neural network, and next time, neural network, we're talking about some challenge. So then we are talking about the challenge or the problem that maybe the CN can be able to help to resolve or elevate it. And then afterward, because with this 2, you only finish half of a conversation. The next half is 1, you need to produce your own ideal. And then encoding them. So for example, I will say, the training size. Next time we say, the neural network really requires a very huge data set to do the training to make them to perform better. And then you know, okay, because of that, how should I encode my thoughts into statement? So for example, because I think the smaller pattern, the filter that we try to talking about, and allow us to check the CNN. Don't need to check the whole big data. We just need to check the different filter part. So because of that, kind of try to expand the amount of training record. Kind of, okay, because we don't need that big size. Or we can chunk the data into the very, very smaller part. So one image is not just one image anymore. They become so many images. Okay, so then afterward, we try to show you what to do that. There's a guy who are very famous in NLP called Noam Chomsky. Right now, it's very famous on or Weibo because he is a guy. He's still alive. You need to know as a computer scientist, live that long is very rare. No pity that computer science do not actually have Nobel Prize. If we have Nobel Prize in computer science, he probably will be the winner. Why? Because he lived long enough. And the Nobel Prize is awarded to the people when the award's being given, they're still alive, right? Do you know? Really? You don't know? The Nobel Prize only award to people, they are still alive. Okay, so then if you are very important, but you die young, to pity, there's no way for you to get the Nobel Prize. Okay, and then and now Chomsky right now is like 98 or 97. Very rare. And then in his early work, he mentioned about something. Say, what is language? Language is a lot of sentence. Okay, each sentence is a finite length. This one is not difficult because you need to know if it's infinite, then there's no way for you to finish about them. And it's also important to know that it comes from a finite set of elements, because finite set of elements, then you will be able to understand what are information right here. The interesting part is right here. They're talking about the structure of language is biologically determined. It's weird. Do you know what it meant? It means that most of the human beings in the world have one brain, one stem right here, stem brain right here. We have the vocal cord right here. And then if our structure are the same, then all the biological organizations are almost similar. Then no matter which language we're talking about, the structure will be the same too. Okay, it's very weird because that guy is so lucky, not just because he lived long enough. It's also around that time when they publish a paper, they don't need to have proof. If I say that right now in my paper, then the reviewer will reject my paper right away. They prove it. Around that time, during the wartime, it's good. You just writing and people just publish. And then they don't need to give you any proof. Okay, so that is why that kind of thing in his paper is no any evidence to show that it's correct, but it's still shown in the paper. Okay, it's not possible right now. Okay, then he also says something very interesting. You can probably will say, Professor, there's no any proof. How come you still say that? Because it's interesting. He said the human are born with innate linguistic ability. Right now we start to having some psychology or some neurologists, they try to study the development of the children and try to understand, do we having some linguistic ability behind that? It looks like he's right. And that is interesting because he say all the structure of language is biological determinants. So you will be able to having something called universal grammar. That is amazing. Do you know why? He say that without any proof. But then, based on what he say, people starting to study the language and starting to study how we can develop different language go through them. So through that, then we're having your high-level programming language. You have the list, you have your C++, Python, Python thing like right here, you can imagine they are got inspired from China indirectly. And also, because he said this one, universal grammar, that is why you will be possible to have LLM. The LLM can only build on top of one hypothesis that all the language might have a very similar structure. If they don't have a similar structure, there's no way you can utilize one language model, one big language model to understand them. Okay. So they say, no, we probably human being were having some one language model because all the human beings born in that way. So you will be able to learn it. Okay. By the way, around that time, no proof. But right now, it looks maybe he was right. Looks maybe he was right. And around 1957, he proposed certain thing called syntactic structure. This one is important because after he mentioned that, the high-level programming language uses his way to construct the different structure or construct the rule and allow you to write your programming language in a much easier way. If they don't have the high-level programming language, you need to write in assembler language. Has anyone wrote assembler before? Raise your hand. 1, 2, 3, you are lucky. Okay. Do you like to write assembler code? No, right? I hate that too. Okay. When I was in college, I wrote assembler. Drawing makes so difficult. You need to do everything, and also you need to know the relationship between the register to another register. I hate that. Okay, so then I decide I want to study PhD. Why? Because I can make my student to work on that. By the way, sometimes we don't have very high noble goal by doing certain action like me. No, I just don't want to write assembler anymore. Okay, so then syntactic structure, let us try to see how we try to working with it. Assume this is a statement. This is the best thing happened in my life. Okay, first what we do is we classify our word. You will find out, because we mentioned this one last time in the classification. We say human beings have difficulty to understand everything right here. So the best way for us is we try to classify them. How we classify them? We call them right here called lexicon analysis, or you can call them POS tag. POS tagging. So right here we say part of speech tagging. Some people actually were talking about POS tagging. It's called lexicon analysis. Try to understand what is the POS tag. Are they verb? Are they noun? Okay. Are they adjective? Why is that important? Because different tags can give us weight. And so, for example, when you try to go to the brainwave to something else, you might find out the most important thing is trying to having the noun correctly and the verb correctly. Having everything correctly, and it will be much better than you just try to put the adjective and the thing in the between. Okay, so then afterward, when you having the pause tagging based on the Chomsky actually do the syntactic structure, right? So what he did is he said after you have the pause tagging, you can do syntactic analysis by pausing them into a tree. And after you have the tree, you will know how you try to truncate your information. So that is something we call parsing. If you took compiler course, you will find out that it is still the same. Okay, compiler course is you need to having some rule. And the parsing actually mean right here, this definition come from compiler courses. It's a process. We actually got some input. We got input. Okay, because this input are being input into the computer, so everything get into this one. We call them token. This term we did not mention them before. The tokens. Why you don't call them a string of word? Why is not called a string of word? We want to call them string of token. because sometimes you will receive certain things that are not word. Like parameter I. What is I? It's not a word. It's a token. Okay, and then when I say that, you also need to understand. For example, right here, I have a word called determine. Okay, determine. It can actually truncate to different tokens. So, for example, I can cut them right here. No ing, or ing belong to something else. And then I can cut them right here. B. Okay, I think they were also having some prefix right here called B something. And turn. So then it will be very possible some people probably would cut them in this way. You might ask, Professor, why you cut them in this way? Why did I go to 2? Yes, you could. They have different possibility for you to try it. LLM did that. Try to truncate your word into token. And based on different tokenization approaches, they might show us some best way of doing that. And you might find out the tokenization somehow being utilized based on our knowledge of what is the prefix of our root or postfix, and so they probably can get benefit from it. So that is why we call them a string of token. Okay, so not string of word. So when I have the string of the token, so what is called parsing in compiler or parsing in our natural language processing is we having some input. If we have an input right here, this is input. Okay, the most important part is I would like to having my generator, so you can call them parser. Parser right here. Okay, and then my parser having some resources. I think you go back right here to get, you can imagine it's like wisdom. And say, I saw this input. I get this input. Can I, based on my wisdom right here, generate some output? I need to generate an output. This output is exactly the same as our input. That is what parsing did. Generate something that's totally identical. But when you try to generate them, the most important part is not about that output. It's about how you generate them. Okay, so for example, when I talk, you cannot just listen. You need to do the parsing too, right? And in your parsing, what you did is, I say parsing is the process of determining whether a string of the token can be generated by a grammar. Then maybe in your brain, you're thinking about what is grammar, and then you have the rule. So many different rules, rule, and then you're thinking about, oh, I need to utilize a rule to somehow form, or maybe this fill in this rule too, and then partial then fill in rule 1. So by combining rule 1 and combining rule partial head of tail of the partial the rule 2, and then I can have exactly the same string as my input. In that cases, then because I actually say right here is the rule 1 and the rule 2. If you know my input can utilize rule 1 and the rule 2 to generate exactly the same thing, which means I can utilize rule approach to understand that statement. So far so good? Okay, I remember Professor Feynman. Do you know Feynman? Feynman is a very famous, he's Nobel Prize winner too. He is a very famous physics. Around that time he was alive, but he already died. And then I remember in his book, he mentioned that how he tried to understand things. When people actually say, oh, today we're having something very wrong, then he's not only thinking about the concept called wrong, in his brain, he will generate a different ball because he's talking about round. Then he will have a ball. And he will ask people, say, what is the size? They say, as big as a basketball. So then he will stay as a basketball. So in his brain, he will have that basketball. And then when they just imagine that the basketball will have a line to cross that basketball. Then he will have an illustration to have a line and then go with the needle to across to the basketball. By the way, when I say that, you suppose you should having a basketball in your brain too. Okay? But if you can do that, so then you will understand. Then say, okay, so after we try to go through the basketball, you have different line and to cross from one to another, to cross another one, and then you try them many times, then you will realize that if you do that well, then they will all the line will meet in a center, a middle. That is a center for that round thing. If you cannot, probably it's not round enough. So for example, if that's the case, then you will have an illustration in your mind. Okay, what is the parsing? Parsing try to do the same thing. So get the output, totally equivalent to the input. And afterward, what you try to do, you go through the different analyzer, go to the parser, and then actually come from some resources. This simple table is my resources. And after you can do that, I can construct the rule, or we call them parsing tree. So that like right here, I know I will having a rule to say, how can I generate a statement? Statement, suppose you should having a subject, should having a verb, and should having some noun phrases, optional. Noun phrases can also having some phrases, try to having the preparation phrases or noun phrases right there. And afterward, then we will know how to understand that statement. So once you're having that tree, we will be able get closer to understanding. Okay, so then we can go to understanding the meaning behind it. And then afterward, then we can actually inference based on our semantic meaning. So this kind of rule, basic NLP rule, being given from the time when Chomsky mentioned about it, from 1957. And then a lot of researchers, because it was success, you can imagine, after 1957, and then people get inspired, and then find out that, they really want to do that, and then come up some programming language, so the synthetic structure becomes very, very important work. And then many researchers just try to follow the way to understand. But we just find out it just takes too long. Too long. So around 2012, the people starting to having a different revolution. Okay, so then that is why we try to go through them quickly, but I think all the going through, so before 2013 or 14 right here, this figure is come from a Stanford professor, Mac Webb, right here, Webb Mac. And then he tried to say, what is natural language's understanding? How can you understanding our language? Okay, around that time, you will find out have different terminology, like semantic parsing and like sentiment analysis, like name entity recognition, or co-reference resolution. They have so many different work from 1957 to 2014. Many researchers try to working on that. Okay, but it's a but. Then this one actually is 2 years ago. I go to Microsoft and they talking about their NLP team, what they try to working with. And then you will find out they still having those things, part of speech and dependency parts. So they're still having that. Okay. But then you will find out right here, they say they have 5,000 more model. And then they can deal with 200 languages. Do you find out what happened from this one right here? Do you remember our data mining phase? We say preprocessing, model, Evaluation. Remember the past? Okay, so can you find out this part become what? Pre-processing. Yes. All the things that we're talking about, like right here, a lot of people actually utilize that in pre-processing. And their model actually go to this LLM model. That is current trend of doing that. Okay, for you to know. So that is why we still need to talking about a lot of LLM model, but we need to go back to talking about those things in pre-processing, because without having a proper pre-processing, your LLM model cannot do it. Okay, so you can actually right now, that is my version. And I find out everyone is talking about LLM. And then even the people who do not understand still talking about LLM. Fine, then we need to talking about that. But we don't have the time to talking about LLM today. We will talking about in next session. So remember, next Monday, we don't have class right here. It's lab 2. So you just listen to the lab 2's recording. We will not meet right here. We're having a break. So many break in October. Fine. And then, so first, this is our class lottery. Oh, we have 3 class lottery, and this one is just the first. The answer is bag of work. Because next one, we are going to talking about bag of work. After today, I hope you do understand what is bag of work. That is our first lottery. No. I need to sit up. Sit long. Three minutes up? 3 minutes is not up, but can I continue? Okay. So, you know how is your holiday? Holiday is busy with the lab 1 or lab 2, or final project, progress report. My holiday, my 2 holiday actually is, I don't really have a holiday. I took courses for the past 2 holiday, each one for that. So just like you guys, I'm busy too. Okay, so NLP technique has so many different things. I'm not going to talking about that, and especially today, I don't have much time. Okay, so then I list them, and for you as a reference, because right now I don't have the time. So in Mandarin or in Japanese, some language, the word do not have an explicit word boundary. In that cases, you need segmentation. So we show you a different way of doing that, but I don't want to talk about that. In post tagging, we also talking about it. You can have the different library. Right here, we try to show you different library we're able to do the post tagging different way. There's no good and bad. Just try it by yourself. And then we also having something called stammer. You might say, Professor, you go through them very quick. Because, yes, I don't have time. And so that's why I go through them. Stammer, what it means is, for example, that this is a word in Spanish, right? Spanish word, right? Okay. Here we have a Spanish speaker. Okay. Next one, welcome for you guys actually from a different language, like you guys, different language. Show me some example like that. Spanish people actually show this one to me. Say this one is wrong. Am I right? Wrong. And then you can actually see in Spanish, and the same word, wrong, have 18 variation. 18 variation. And then is like beginning of the row. This one, beginning of the row and middle of the row and after the row.
Yeah.
The time, right? It's because their row actually having a different stage with the time. And then actually it's also having the gender, right? And also the gender we're having, it will be plural. I mean,
There would be like the people is.
How many people?
Singular.
singular and how many people? Anyway, you know, that in the end they have 18 variation. No, I remember before I have a student come from Kosovo and say, Professor, that is really not good. I say, why you need to utilize our language? They only have 18 variation. We have 27 variation. So okay, fine. And after he graduated, I forgot to get that information. So if your language have more variation, let me know. In Chinese, we don't. One word. But you can actually imagine that Spanish people, they are smart, right? They're very smart. They just utilize one word, not all the context. How smart they are. And then so you can imagine their brain are constantly trained by that. Very good. So then, okay, why I say that? Because the difference, because their word actually having too many variations. If I want to do the statistic about that, it actually would make the word is not that significant. So Stanford is trying to chunk out the end part of it and make you to having a meaningful statistic. That is the part. So we try to show you some example. If you don't believe, then it's fine because they have different variation. Okay, just assume you already understand it. Okay, and why is that important? Because today I really want to finish it about the part. No, it's just like you guys in your the lab one, your final project progress report. You find out that you just have 4 minutes. What you try to do, you speed up, right? So some student will say, Professor, why are you actually getting faster and faster? Because I run out of time, so I speed up too. Okay, for today, our class, one very important thing is you need to know they have different way to do the representation. Okay, and then two different representation that we want to talking about too. And unfortunately, I don't have the time to go to LLM. But the second representation I'm going to talking about is like the foundation of LLM. I think after you knowing them, go to LLM will not be that difficult. Just go to the lab and the TA will try to talking about the thing. So remember our lottery's answer, bag of word, right? You see that right here, bag of word. Okay, so that is a very important concept for today. What is bag of word? Because the bag of word really means a bag. It's a bag. And then right here, you put so many words inside. You utilize that as a unit. That's what you call bag of word. Okay. And so you can have many words. Right here, we probably can call them keyword or term, depends on what we say. Or sometimes you will hear people to talking about token. It's fine. I think token, term, keyword thing, they've been utilized in different places. But you try to check the paper. Sometimes they will say keyword is meant about something and token is meant about something. Okay, so then let's try to see bag of word is I want to convert my document into a vector. That's it. Convert them into a vector. Why convert them into a vector? Anyone know? Why vector? Why vector? I hope after the attribute part you guys starting to understand. Because once you convert them to vector, every value inside the vector are racial data. Okay, inside each one of them are racial data. It's quite easy to utilize any mechanism like SVD, SVN, or whatever, or even traditional neural network. If they are racial data, it will be a lot easier for us to do all the computation. So convert them to vector is a very important skill. Okay, you will find out when you try to do your final project, you have a lot of value. In the end, you also need to convert it to vector because your model probably understands the vector. So vector space model is you get input document, you convert them to become racial data, a vector of racial data. And how we try to convert them? What we call the bag of word. Okay, first you have the bag right here. Okay, you see my illustration. In the back, I only care about what word inside the bag. That's it. So you might find out because then they're right here. So right here, I have to fill word in Mandarin. I'm sorry, it's in Mandarin because it's interesting. Okay, I can say that I owe you money or you owe me money. Okay, I owe you money, you owe me. The things I cannot utilize English because it's like I and English have I and me, and then it's different. So then you know what it means. But in Mandarin, the part I like Mandarin is Mandarin is very vague. You know why Mandarin is very vague? They have a history reason. In ancient China, because we had empire, okay, and sometimes you cannot say too clear. And why is that too clear? Because if you say A too clear, there's no way for you to argue them back. So you need to do the very vague way. And empire say, are you saying me the bad thing? No, empire. Holy Empire. I think a good thing about that, so I can kind of translate back. That's my own version of that. And so in Mandarin, because it's very vague, and if you put it in the back word right here, you will find out without order, things might got wrong. Okay. In English, it was also possible with certain word right there. So usually, you will in the back word, you heard about another term called n-gram feature. Mean how many words inside a bag. How many words inside a bag called n-gram. So for example, here is the word right here. I can do n equal to 1. So in the n, I go sliding window, go for many different things. Or I can do n equal to 2. I can have so many words go right here, n to 3. So n to 2, I will get this one. If that's n to 3, and then I will get the different word. So then different n will show me the different output. Which one is the best? We don't know. Common way in Mandarin, we probably will try your n to 2 or 4. That's it. In English, your n actually means this one. 2 words together. Okay, just like that. Okay, so that is called n-gram. Okay, after a word, then let's try to do the example. Here you can see some statement. I'm sorry, but I need to go to slide 2 right here. Okay, you see some statement right here. If each one of them, each row of them is a document, just assume they are document. I try to select the statement that are short. And then I do having some concept in my mind, say what are the important key concepts I want to show you. Okay, and in the end, what are the most important keywords you would like to choose from this corpus? Choose 5. So go to the slide 2 to choose 5 keywords that you think they are important enough. Why we need to do that? Because back of word, there's no way for us to input every word right here. In the end, we can only select the representative word and convert them into a vector. Then right here, the first thing is try to select the important keyword. Okay? So the statement right here, choosing a word. No, there's something I really want to talk about. They have some knowledge, they have some wisdom. Knowledge you speak, wisdom listen. Do you know what I mean? I have knowledge because I speak. You are wisdom because you listen. Don't you feel it's so nice? Trouble is you think you have time. You just don't when you do the final project. And in your 1 minute reflection, you will ask some question. That's wonder is the beginning of the wisdom. Enemy of knowledge is not ignorance, it's an illusion of knowledge. So you think you know, but probably you are just having an illusion. Okay, so actually I picked some statement because I think there are very many meaningful. Even though you forget everything we're talking about, if you just get it, then you have wisdom. How nice. Okay, I think you guys already picked, right? No? Okay, so let's try to see what you picked. Hey, how come they only have two? Where's the rest? They're just gone. Too bad. Okay, so I stopped right here. I'm sorry. Something go wrong. Okay, but then you can find out. You can do one thing. I'm sorry that something go wrong right here. Okay, you pick the 5 keyword right here, and then I will try to go through my method, and then afterward you try to see does your 5 keyword is the same as my 5 keyword. Okay, fine. So I'm sorry that right now how come I only have 2 in the lab. Okay, so then first thing, because first one we need to know what are the first 5 keyword. Assume it's a 5 keyword. So what we try to do, you heard about some terminology called TF-IDF. TF stands for term frequency. So when I pick a keyword is supposed to have the meaning is that they repeat many times. Go back right here. Which word repeat many times? Knowledge. Repeat many times, right? Time repeats many times as well. Wisdom, probably you actually have the feeling about it, probably repeat many times. Okay, so term frequency is what people are thinking about why they are so important. So then you can actually see when we're having the term frequency, the TF stands for term frequency. And the first thing we want to talking about is we can calculate about term frequency. In the end, does the knowledge have the most term frequency? No, you find out, no. The most term frequency is is. Do we mention is important keyword? You don't. Right? So that is why we want to introduce the second thing called IDF. Why we actually do TF-IDF? Because originally we're thinking about frequency supposedly is the most important one. However, when I try to show this one to you, you will find out that, oh, some words I did not think they are important, but they appear a lot. Like those things, we call them stop words. Okay, stop word. It's like they keep on showing up. And then when you try to read those things, you probably stop right there because so many different things. But the important word right here, like knowledge, they are not having a high frequency. So how should I boosting them up from my selection? So then right now the term frequency, I show you some equation. I'm sorry I don't have the time to go through them. One way is you have some term frequency, but sometimes you will know one thing, that is they might having certain words, they are repeatedly so much. So we want to somehow deduct the importance of them. Then we need to try to do certain things, we call them normalize. Like for example, if this is a distribution of the word, this is a number of the time that the word appear, you will find out most of the time it will look like that, power law distribution. Some word just happen a lot, so many times. You don't want those things because what you want is something in the middle. That is the word you want to pick. But how can you do this one? When you try to do the normalization, it probably can help you to do with it. Okay, so then afterward, we want to remove the is, the, all, something like that. So what we do is we do IDF, inverse document frequency. What it implies is if there's a word repeatedly in the document, they actually show up in all the documents. By the way, TF-IDF is actually being invented when we have an application called information retrieval. What it means, just like what the Google did. You type the keyword in, they need to return the page consists of that keyword. Okay, so you want the keyword that are representative enough. They don't show up in every document. So you will penalize the word that show up in every document. Okay, understand what we mentioned? And then because of that, they utilize the term, like right here, to do this one, they do log. And I think in the 2 or 3 sessions ago, we're talking about why important about the log. So I don't want to talk about that right here. And then afterward, you can see the document frequency is they actually show a lot. And then our IDF, we utilize that equation, we can calculate this kind of IDF. You can actually see those things like a beginning, experiment, illusion, money, wonder right here. Their IDF are not being penalized because they got this thing, they still have. Okay, TFID is term frequency multiply inverse document frequency. And then you actually will find out, like right here, the if show up a lot, right? So then based on my IDF, they will be penalized. They will get lower value. So once you try to do this one, okay, so then assume your document is this one, and my term frequency is this one, and my IDF is this one. So then afterward, my TF IDF will show like this here. You probably will say, Professor, how come this is the still show up right there? Because then we have a very short corpus. In a very, very big corpus, and then I actually try to intend to select all the statement related to knowledge. We will make the knowledge become not that because they show up in too many documents. But then right here, you can actually see originally, okay, for example, like time right here is supposedly should be higher than this part. But then because the time actually show up in many document, and like layer and you only show up in one document, so the document frequency, if they did not show up quite frequently, they will get some reward of them. Okay, so then afterward, what we know is like we have the TF-IDF to rank the importance of the keyword. Then afterward, assume we say we use a certain threshold. This threshold can be I pick the top 5 keyword. Or actually right now I say, okay, I utilize 1.8 as my threshold for my TF-IDF value. So that I eliminate all the words that are less than 1.8. Okay, so far so good? And then after that, I will have is the knowledge of their U time, right? Being picked as the important keyword. Then after that, that is what we did. I turned them into vector. So that is the vector I'm talking about. Okay, so far so good? Back of word. Because then this document will be represent as that vector. 1, 1, 0, 1, 0, 0, 1 vector. Okay, that is the back of word vector. Oh, that is clear? Okay, so then this one being invented around 1980. This approach is being invented around 1980. And from 1980 to right now, and they have different variations. So that is why there's certain variation we did not talking about, like BN25. Okay, you can check their paper. They utilize more statistic way to say how we can calculate that in a better way. BN25 with the TF-IDF and with a bigger word, many people believe that it can still become a very, very good baseline. Okay, so you can imagine something like this one. Go to check your brainwave. So maybe they do having some word being selected, you test TF-IDF, and then they are likely to become the output. Okay. Okay, so we finish about the bag of words, and then we go to a lottery 2. I'm sorry, I'm really, really late for today's session. We'll make our last part quick. When you try to input this class lottery, let me try to say something. Well, some people usually will find out that I go through them very quickly. And then we can imagine the first round of the spiral actually is given by me. Okay. And then afterward, go to this part, you do your 1 minute reflection. These are your 1 minute reflection. Or you go home. So this part is for you. And next time when we come back, we're starting from right here. So we can get slower because you can see that the circle is not that wrong anymore. And then after that, do everything by you. And then if there's anything needed, then we come back next time right here. And I think that's the way how we try to learn the concept. Okay. By the way, remember, class lottery, the answer is still bag of words. Very important. We will say that for 3 times today. Okay, so next one, we want to talking about another concept called word to bag. Okay, and the word to bag actually, because you can see bag of word come from statistics. Think about that, come from statistics. You have different statistic way to say, okay, based on that, when I do that calculation, that is important. Okay, and based on statistics, we also say, oh, based on that, this one is important. But there's a but. Okay, the backward have certain limitation. First, once I select them, so for example, like right here, okay, I don't care, does this knowledge actually have a, right now we do not select wisdom. Assume the wisdom is being selected. And then you say, oh, knowledge and wisdom, they're quite similar. Can we merge them? Right here, no, because they are different. So not any semantic meaning actually is being considered right here. Okay, this one is a little bit unrealistic from these people's mind. And also, if you want to select many dimensions, just right now in our illustration, we only select like 7 or 8 words. But in reality, you probably need to select 10,000 or more than 10,000 words. And then we will encounter a problem we call sparsity. Like a document, they are not going to have all the words right there. They only have few words, and the rest of them are 0. And then because of that, we will also suffer the curse of dimensional problem. So they have a very bad thing about the vector word, but people cannot find a good way to solve it until around 2013. Okay, a guy from Google, that's what people feel is weird. People are always pioneer. How come right now it's like OpenAI is a pioneer right there? It's weird. But the Google, there's a people from the Google propose one thing. They really want to solving the semantic problem. Okay, and they're thinking about that, saying that how can we solving the semantic problem? Can I utilize context? Again, here you heard about the term context. These are contexts. Assume I want to know what is doctor. What is doctor? You have the dictionary of the word right there, but maybe we can utilize the document consists of the doctor and then see what are the nearby words of the doctor. Utilize nearby word to represent doctor. So that is the original intuition of the word to back. Utilize nearby word to represent the meaning of that word. So far so good? So you can actually see in this meaning, this nearby word in our example. What is doctor? Doctor have some nearby word, medical. Okay, they have a word like a patient, injury, illness, diagnose, medicine, something like that. So you will know doctor, medicine, illness, injury, disease, patient, they are somehow all related. You utilize that word, try to represent them. Okay, so then if they say, okay, so if that's the case, can we utilize the neural network model to train that? 2013, they're talking about it. And then afterward, they got this amazing output. What is amazing output? They say if I get a vector, before I don't have a vector of the word, I only have king, man, woman. But then they say, can I generate a vector to represent king? Can I generate a vector to represent men? If I can be able to do that, by utilizing vector of the king minus men plus woman will be equal to queen. Why? Because it's really our vector composition. King minus men, so then equal to this part, adding woman, and in the end, they become queen. Amazing. So then they are having that tree. And in the end, they really can do that. Okay. But you can imagine how they can do that. Because you can imagine when you're thinking about the vector of the key, you are not only thinking about key. That vector represents all the context words surrounded by key. Okay, all the context words surrounded by king could be ruler, order, ceremony, thing like that, Okay, and then when you have the words surrounding by men, you have all the things that men did, right? All the things men involved. And then you try to add minus what all the men will do, okay, and adding all the women will do. Women will do something more than men. What? Usually when you see in newspaper, when you see a man or when you can see a woman, what you saw? I can tell you my observation. When we're talking about women, usually we will see a lot of description about their clothes and about their makeup, right? They dress this one and then Chanel shoes in this one. How much dollar? That's a bag and thing. I mean, every time when I see they describe Prince Diana or Prince Kate right here, it's just like that outfit. And then the lipstick is what kind of a brand right there. Okay, so but then if you actually did this one, you actually see the king. Right now it's King Charles, right? Is anyone talking about his makeup? No. His clothes? No. But then when you actually remember the Queen Elizabeth, yeah. Okay. Then we also mentioned about the outfit, right? And so you can imagine all the keywords surrounding by them, and then the keyword we represent them you as a vector. How we do this one? That is the idea of the word-to-vec. In the word-to-vec, the proposed two model, all of them are neural network model. The continuous backup word model, continuous skip-graph model are just neural network model. But then they utilize different way to train the neural network model. Let's try to see how they try to do this one. But before that, I want to talk about a story. I'm sorry, it's out of time. I still want to talk about a story. Did our international student know the story? Okay, this is a very famous story in Taiwan and China. Okay, it's talking about there's some. So by the way, that is fiction, but people still like to talk about a story. They're talking about there's a genius. It's a genius, and the genius he actually will try to direct army. So they have the two troops to fight to each other. In this genius, so right here, the genius is group A, and there's another troop, group B. Troop B is very rich guy. So many soldiers, so many weapons. And A is very poor guy, not many weapons. just like you can see B is OpenAI and A is you. Okay. And then because rich guy actually they can do so many things, but A actually do not have it. So but then they want to fight to each other. They want to fight each other. In the ancient time when they need to fight, they need to utilize arrow to shoot and to fight. They run out of the arrow. Okay, they run out. So then they definitely will lose because they are not rich. They run out of it. So then genius actually say, don't worry. 2 days later, I'm going to give you so many arrows. You have a bet with another person, with another team C right here, assume. Okay, say I'm going to do this one. So then how you try to do that? In a very dark night with a lot of noise. So they have a lot of fog. Okay, fog come in, and so not easy to see the boat. And then send the boat out. On the boat, they do not having too many soldiers. They only having so many fake guy squirrel right here. And then right here, but then they were having 1 or 2 soldiers, and then you apply the drum and thing like that. Okay, something like that. Okay, hope I'm not too noisy. And then afterward, they just do, and because it's fog, it's not safe to come out to have the battle. So their enemy B will shoot a lot of arrow to them. And then you understand the thing, so you see a lot of arrow. So then that A team, they come back, say thank you, and then they come back. That is the story I want to talk about. So far so good, understand? So you know what they did? They fake to have a war. That's one thing. They fake to having some war because they're doing, and then people starting to shoot, right? So from the B's point of it, they think there's a war coming, but in the end, they don't want to battle with them. They just want the arrow. That is the concept of war to bet. After I finish that, then you understand what is war to bet, right? No, you don't. Okay. So then we want to tell you that. So remember that story. Okay. So the continuous back word model, what they did is they try to define what is called context word. Context is word, just like what we do about the doctor, surrounding word. I utilize the bag of word approaches to get a bag. Inside the bag, that is my, so here we call them target word. Actually, that is my answer. Just imagine that is my answer. I ask my neural network by getting the context word. So here are my input. So context word are my input. Target word are my answer. Okay. I want the neural network to learn if I receive this input. Okay. Can you classify or predict the correct output for me? So correct answer for me. That's it. So I input this context word, and then let me try to do this one. One-line coding I will talk about later. So I input here is my input. I input I am good pizza, right? Because I am good pizza and my context word. Okay, and my output should be eating. I tell the neural network to learn that. So very good. Okay, so then, but we need to go back. So how we try to do this one? You can imagine my documents are long. So I utilize n-gram approaches to do the sliding window and moving. Assume my n equal to 5. And my n actual moving. So next one, right now, my context was I am good pizza. And then I probably was moving. Animation did not do well. Okay, so the next one, I was moving to another 5. Right? And then good will be my answer. And eating pizza now will be my input. So I do the same thing over and over, try to moving all my sliding window from beginning to the end. So far so good? Okay. So then afterward, one thing I did not talking about, but I think some project already mentioned about one-hot encoding. Especially in NLP, we do one-hot encoding. It's because you don't want to confuse. So for example, if you're saying that the word is one, and then this one is if you input 1 and 2 and 3 and 4 into your machine learning code, and then we're thinking about, oh, supposedly 3 should be bigger than 2 or 4 should be bigger than 2. They consider it as racial data. You don't want them to be considered racial data. You want to classify them as a categorical data. We convert them into one-hot encoding like that. So one-hot encoding is each one of the digit is a class. If you get 1, which means that belongs to that class. And because there's only one, so that is called one-hot encoding. Only 1. And we say the 1 is hot. Okay, so one-hot encoding is mean inside your encoding, there's only one. Okay, so then for example, based on that, I can say my I am eating good pizza now can be converted to those encoding. So you can actually see I actually do one thing. 1, 2, 3, 4, 5, 6. 6 digit. Each one for, so 1, 2, 3, 4, 5, 6. Each one for each class. And then this one represent I. This one represent N. So first good, understand what we're talking about? Okay, so after that, we convert them into one-hot encoding. And then in my input, you can see I directly put those input inside. And what they did, right now, let me try to, so you understand this input one are I am eating good pizza. So what I did, I put them together. So then I will know my input is 1, 1, so adding them together. So it will be 1, 1, 0, 1, 1, 0. Okay, so far so good. I adding them. So for example, then my input are really just, because there's only one, and the second one is 1, and the third one, no one is third one, and then there's a 4, 5, and 0. So that will be my input. So far so good. Okay, and I put my input right here, and then I know this is my output. And then I will say, okay, so if this one is output, and then you need to somehow try to show to me. Okay, so then all the neural network right here, they are trying to learn so hard to say, oh, how can I guess if this one is correct to that, this one correct to that. So rest of them are all the neural network model they try to working with. Okay, so first good. So that is this is a fake word I'm talking about. Right? Fake word. I tell them that you need to somehow do this eating. There's one thing that we did not mention before. Okay, that is this part. You know this one. This is traditional neural network. Right? This is input. There's something in between. It's called W. There's something in between. What is that? Because if you learn the linear algebra, then you know the matrix, if you want to multiply them together, you need to make sure that your matrix should be in the correct dimension. Okay, so this is a dimension, this is a matrix to allow the two different matrices to be multiplied together. So you can imagine it's the middle bridge. Okay, so and after they learn this one, okay, what we do is before, when we try to use a neural network model, we actually rely on softmax layer to say, oh, can I tell you that which is a class? No, after they learn that, they don't really care. They care about that part. They care about W. So when we actually having a W, what the W means? W means that today, if I've been successfully to knowing this keyword mapping to this one, my W should have all the correlation to say this one, how it related to another word. Okay, so then afterward, I utilize the W, and remember my every input, like my word itself, is one hot encoding, and there's only one. So I utilize my one hot encoding, multiply W, then I will get some vector. I utilize that vector as my representation. That is my arrow. So far so good. I make the neural network model to actually see what is the relationship between the word together right there. And then afterward, the neural network model tries so hard. And in the end, they having something very good. I say, okay, thank you. Then I don't really need that. I need something in the middle. That is W. I utilize W, multiply my one line encoding, and for every word, I can get this hidden layer vector. That is what I want. Then I utilize this one as my representation. Get it? Okay, so but you say word-to-vec actually have two models. This one is called continuous vector model. They have the rare. So for example, if you have the word, they did not appear for many times. You cannot learn them well, right? Because you suppose you should learn something well if they've been seen in different occasions. In that cases, they try to utilize another word called skip word model. What is that? They are almost the same, except for they actually, before I input this context word to learn the target word. Skip word model try to input target word to learn the context word. Okay. It's only the direction is different, but they actually call them a different name. And afterward, in their model, they actually will find out they really can have the vector. The olden country will be belong to one vector, very similar, and the different object will have different kind of vector, and they really can perform the thing like the queen equal to king minus man plus. They can really do that. So in the end, afterward, we want to tell you that actually after 2013, the natural language processing field are not the same anymore. They're doing very different. How different they are? Because then people starting to utilize machine learning approaches, not backward approaches dealing with them. So they belong to two very important representations that we want to talking about. But the similar idea I actually proposed before. In 1986, there's this guy who got the Nobel Prize winner for physics. He was surprised that time. What? Okay, and Jeffrey Hinton. In the 1986, they also talking about they can utilize backward propagation to learn the representation. But not many people pay attention to that. Why? Because around that time, machines are slow. They don't have many data. They probably only have thousands of the record. Just process 1,000 record, they already consume a long time. So then they cannot do very well. But then the similar idea being wait. And you know, at the time when the word-to-vec, those people actually having that paper in 2013. I remember Jeffrey Hinton are still the chief scientist for the Google around that time. So I'm not so sure I've been influenced. So some ideal, very good, but they need to wait. They wait for how long? They wait for around 25 or 30 years to make them to become very shine. Okay. So sometimes you need to tolerate this loneliness. This is our class lottery. Third one for class lottery. Open them. Okay, so when you try to fill in them right now, you do that. And then I need to go through them quickly, talking about summary. Our summary today, we're talking about different traditional NLP technique. We have lexical analysis, pulse tagging. We have parsing, we have semantic analysis, and then we have inference. Of course, we do not talking about this, and we emphasize more on this too. And then we actually talking about different terminology like word segmentation, pause tagging, stemming, backward word. And the backward word, one very important keyword is TF-IDF. Okay, if you don't remember the equation, it's fine. Don't worry, I'm not going to test you about the equation in the final exam. But if you want to write that in your A4 sheet paper, it's fine. It's a good thing to starting with. And we ending with word to back is we call them. So then right here we want to talking about them. Back of word. You might heard about the terminology. People call them sparse representation. Sparse. Because they have the keyword, you have the vector, and it's very sparse. Not every word actually being having the value inside, so it's called sparse representation. In certain paper, people will not directly tell you speak all back of word or the word to that. They will say that is sparse representation. All the machine learning way, they is called word to back. So this one is called dense representation. Okay, so then maybe there's something I forgot to mention. There's one very important thing right here. Okay, the W actually can be choose, manually select. So for example, right here in our example, our input is 6 dimensions. So we need to think by something. But then right here, we buy 3 is because we are assuming our hidden layer only have 3. So then you can imagine if your hidden layer are 100, then this one will be 6 by 100. Okay, so the dimension can be chosen. And most of the time, people actually were choosing about 100 or 200 dimension. So everything will be squeezed into the 100. It will become very, very dense. So dense representation you found in that vector, most of the value, actually they are not 0. Okay, in that vector. So they are called dense representation. Okay, so then the dense representation for those vectors, we somehow would know the semantic relationship from the word to another word. So if you utilize LLM or utilize so many different things, they actually will show you representation. They utilize similar concept. Okay, totally similar concept. It's just the way they learn the vector are different. Okay, so we can convert. How we try to do with that? We need to first convert the word utilize one-time encoding, and then we send that to neural network, and neural network utilize the way to get this representation. That is how we try to get with the word. Oh, that is fine. So here are the one major function for